Okay, so this is just a quick video for Form 2 for working out ratios to write formulas. As you know, I'm a big fan of the periodic table because it just solves lots and lots of problems. So an exceptionally quick recap. This column here, we call it group 1. It has 1 electron in its outer shell. Here we call it group 2. It has 2 electrons. We kind of skip over these guys, the transition metals. We then go to here, we have group 3. That's going to have 3 electrons in its outer shell. Group 4 is going to have 4 electrons. Group 5, I'm running out of room, is going to have 5 electrons. Group 6 is going to have 6 electrons in its outer shell. Group 7 is going to have, you guessed it, 7 electrons. And group 8, this is who everyone wants to be because these guys have 8 electrons in their outer shell. And there is an exception, and that exception is going to be helium because helium will only have 2 electrons in its outer shell. So when we write our electron configuration, we write it as 2, 8, 8, and we go as far as calcium in junior cycle, so it would have an electron configuration of 2. And if you look across the rows, you will see that in for the first row, it has 2 electrons. So that would be your inside shell with 2 electrons. In our second one, there's actually 8 boxes if you count across. So our second shell would actually have 8 electrons if we were drawing it for something like neon. And similarly for the next row, so we'd repeat that. And finally, because we only go as far as calcium, it would have 2 electrons in its outer shell. So when that's all put together, that is 2, 8, 8, 2. And always say, if you can, pair your electrons because it just makes it really, really easy to count. So, that was not a good circle. So for our good circle, it's just 2882. And obviously this is calcium, and if you do your 8-man, calcium will have 20 protons, it'll have 20 neutrons, and it'll have 2882 as its electron configuration. And if you add all of that up, that makes it 20 electrons. So that was what we did in Form 1. Now we are in Form 2. We're looking over here where we're having to work out ratios for different to write formula. So the ratios is the key thing you're going to be looking for in a question. And we have said that we have numbers that we put over our periodic table now. So we have 1, 2, 3, 4. And this 1 refers to group 1. This 2 is referring to group 2, 3, and 4. And what we're saying here is these guys need to lose these electrons. So that is our blue side, and then we start going 3, 2, 1. So this is for group 5, group 6, group 7, and this are the electrons they need to get. So, and again, it's all to make full outer shells and happiness. So we're going to use what I call the drop-down method to work out our ratios, and we have some rules. So firstly, you need to figure out the elements that are going to be in. They may give you a compound name. So if we have something like potassium sulfide, so you need to figure out what are my 2 elements. So I'm hoping you're saying K for potassium and you're figuring S for sulfide, and we're using the numbers that we wrote on top of the periodic table here. Okay, that's really important. So the numbers from on top. So K lives in group 1, so it gets a 1, and S lives in group 6, so it's getting a 2. And we're going to drop the 2 over here, or the 1 over here, and the 2 over here, and we rewrite our numbers. So it's going to be written as a 2 and as a 1. And that's telling us our ratio. This is our ratio. So now if I have to write the formula, I am just going to write K2S. And we've said chemists are really lazy. We could put the 1 in here, but we just don't to save time. Okay, so the next one that we're going to look at is going to be calcium iodide. So again, we're figuring out our elements. So it should be Ca for calcium and I for iodine. Calcium lives in group 2, so it's going to get number 2 here, and iodine lives in group 7, and again we're looking at the numbers that we wrote on top, so that's going to get a 1. We do our crossover, so it's the numbers that we're crossing over, so we are going to have 1:2, and that is our ratio. So now when we write our formula again, it is going to be Ca, we don't write the 1, I2. Try 2 more and then we will give it a go, or leave it there. So if we were to do aluminium oxide, so if you want to pause now and see, can you find what the formula this might be? So our elements are Al and O. We know that aluminium is in group 3, and we're looking at the number that we wrote on the top of our periodic table, so that gets a 3. And oxygen is in group 6, and the number we wrote on top of the periodic table for that is 2. So we cross these over and we will get a 2:3 ratio. So when we now write our formula, we will write it as Al2O3. And we're always looking for all of these, is it the simplest ratio we can do it? And none of these are all the simplest ratios. We don't have to do anything else with that. Our last one is going to be sodium bromide. Now sodium is one of the funny ones because its formula doesn't kind of match its name, because it's taken from the Latin for natrium. So we have an Na and we have a Br. Sodium lives in group 1, and the number we put on top of our periodic table was 1. Bromine lives in group 7, and the number we put on the top of our periodic table was 1. So we're going to drop down. When we do, we have a 1:1 ratio, and the formula for sodium bromide is NaBr. So the last one I want to show you just before we finish is one of the ones where we wouldn't get the simplest ratio. So magnesium oxide. So magnesium, we have the elements being magnesium and oxygen. We know from the number we put on top, magnesium is in group 2, but it also gets a number 2 on top of its column, and oxygen lives in group 6, and it also gets a number 2. So we drop down, and when we do this, we get a 2:2. Now this is not the simplest ratio that we can get. So we're going to divide everything by 2, and we now get a 1:1. So when we write our formula, we go MgO. Just to say, some of my students have found it helpful to actually box these little columns for themselves, and then they know that for calcium it's 1 and for iodine it's 2. So you may find that helpful. So that's the line we're working out. When we cross over, we're interested in what is underneath the Br when we get to the very bottom of this drop down method. So I hope that makes sense to you.